Welcome to Inside Builder channel. Python experts, problem solvers, and my dear friends. 7 ways functions supercharge solving problems. Let me zoom out. These are the 7 ways in which the functions supercharge solving problems. So, how these 7 steps that you are looking here are going to help? First, improve coding experience. Functions actually improve coding experience because once you have something that takes some 10 lines compressed into a single line or a single word, your coding experience drastically improves because you get a lot of things done in a very little amount of typing. That is linked with the removes repetition. What happens is, instead of doing some 10 steps to complete one activity, if you are able to write that entire activity in a single step, the number of mistakes that you make reduces. Third, it allows us to think on what versus how. When you are working on a complex project, there is going to be a lot of tasks and a lot of small problems that you need to solve. Each of these problems can have various ways of solving. Let's take an example of multiplying two numbers. You can multiply two numbers by using arithmetic, using abacus, using your manual way of adding one number after another. There are various ways to do a simple multiplication. But at the end of the day, when you are going to solve a complex problem, all you need to think about is that, okay, I want to multiply two numbers. That's what we want to think, right? How that multiplication is being done is not of our concern. So once you are thinking about the what, then the problems can be broken down very easily. After the problem has been broken down, each of the problem can be approached and thought how to solve it. Functions provide us that ability. In continuation to allowing us to think on the what, it makes it easy for testing the function, because at the end of the day we are thinking about what output a function has to provide, what modification or what kind of change in the real world the function has to create. When we know that is the target and what is the output the function is giving, we can easily test it. Instead of testing each and every line of code and see whether that code line has executed correctly, we take some bulk function and we check whether the function is working appropriately. This speeds up the development. It also improves the coding experience. It removes errors and it allows us to think what versus how. It is all linked, right? Next is providing help. When you are going to club a couple of steps or the various problems that is going to be solved for completing a single task, you actually document those ideas that you used inside the task as help, and you also provide the instruction how to use that function inside the function itself. So the document is actually inside the function. You are not separately writing it. The code, the developer itself writes the document as he continues coding. Especially the comments. In case of Python, there is doc strings. All these things work together and it helps us to make the life of those who are going to use the code way more easier. Use the function way more easier. It hides complexity. Functions hide complexity. This particular feature is very similar to this particular feature where it allows us to think on what versus how. When you are thinking about the overarching problem that you have to solve and the steps or the tasks that you need to complete, you don't need to enter into how these tasks are getting done. So that is called as abstraction. These two are very much similar. And finally, it allows to reuse, that is importing and exporting. Someone writes a solution for a particular code somewhere in this world. All you need is to have an internet and download the script that he has written and reuse the script. But what if the same person has written some 200 or 300 different scripts, and how are we going to document them, and how are you going to club it together, and how are you going to import them? It becomes tedious, right? To facilitate uh, such a kind of import and export, these scripts are converted to small functions, and functions are placed inside the script, and the import of that entire script, we call it module in Python, the entire module is imported. And after the module is imported, each of the function inside that module is also accessible. That is how functions are supercharging solving problems. Now, I have introduced how the functions are supercharging solving problems, but how can we implement it in real life? If you have been following the series of videos that I am making in this playlist, you would have already seen there is a discussion on applying logic, how the logic creates senses in the machine. This particular discussion where how the 8 ways of use logic to breathe life into code, we have discussed this. The same code, we will actually convert it into function based code. And when it comes to function, what happens is we have to think about what is the problem that we are going to solve. The problem that we want to solve is, we want to look at a capacity of a particular tank. We want to check whether the available capacity is there is available capacity for filling the fuel. If the capacity is available, then we fill the fuel, and finally we print the expense. And in case if the fuel is filled more than the capacity, we show the status that fuel has been wasted, and then print the expense. In case if the available capacity is less than available, there is no available capacity, then we also do nothing. This entire process of trying to fill a simple fuel tank, if a machine has to do, so machine will be doing it like this only. So it has to go through this entire process. It has to get the capacity, it has to get the available fuel in the tank, it has to think about the status, because someone is going to look at it, right? It has to show the status, and then it has to decide whether the capacity is whatever is available is less than the capacity. If it is only yes, then it goes for filling it. If not, it doesn't. And once it is filled, again the status is shown, and finally the expense is printed. Printing the expense, showing the status are all functions here. So you see, I am showing the status here once, twice, thrice. Okay, I'm doing it 3 times, and showing the status is going to involve a graphical display of the tank and the available fuel. That is going to involve considerable amount of code, at least 4 to 5 lines. And I'm going to do it 3 times. So it's going to be 12 to 15 lines of code, and with the necessary comments in the middle. All these things are going to be abstracted. And finally, the printing the expense. Printing the expense is done at the end. This expense can be later modified. If you want, you can add additional information on the fuel types. You can make some modification on how the expense is printed, where the expense is, the data is returned to. All these things can be modified. Also, did you notice that we can start, there is something called as starting the main. That is, when we are going to use the script for importing and exporting, and when you are going to use the same script for executing, how will you tell the interpreter that, okay, I'm importing the script or I am going to execute the script? So there is a mechanism for that also. All these things we will see in next 10 minutes. Let's now dive into the code. The code starts with the objective. So the script introduces how functions supercharge the problem solving. It is very similar to how most of the my discussions are. Here is the function, the show status function, and followed with the expand function. The show status function starts by taking in couple of information. So it takes the capacity, it takes the available value, and it is also taking something called as is overflown. And we are also seeing here there are something called as args and kw args. We'll come to this in a couple of minutes. We see the help here. So this particular function, it simply says that shows the tank fuel status graphically, and then it goes on printing the capacity using some kind of a cryptic code here. It prints the capacity. This looks very straightforward, and again there is something which is getting done here in the print. It doesn't look like a number, or it doesn't look like a string. Let's see how the output is. And here some checking is being done, and then if there is some overflown becomes true, then it actually tells how much has been overflown, or else it just prints the available value and it returns none. Functions have to return some value. That is how the programming language works. If the function doesn't return, then it actually returns by default none. That is how the Python programming language works, and most of the other programming language also works. The reason why it is being done like this is the interpreter or the processor at the back end has to know that the function execution has been completed. So logically, once the function is called, the function, after it completes, it has to return back telling that, okay, I have completed my job, and it will ask the processor to take over. So that is how the return statement works. So return is important. However, in this case, even if I don't provide this sentence, still provide this statement, still the function will return none. So that is one of the inbuilt feature of Python. Next, this function called expend returns the total expenditure on the fuel. It basically multiplies the fuel cost with the purchase value. As simple as that. And here you can see that it returns the multiplied value. It does nothing else. It just takes two values, multiplies it, and returns it. If you come here, you can see that it just it provides the print expense. But here, when you're looking at the flowchart, you actually don't see from where the input is coming. We are just seeing the flow here. Here, the flow is not about the inputs. It's about how the control is getting flowed. Okay, after the available capacity, show status activity is done, and after that, print expense activity is done. Here we are not looking at the inputs. So when you are looking at the flowchart, we have to be careful about whether we are looking at the inputs or looking at the flow. If you are looking at the inputs, here even you might be thinking, this looks as if you are getting the input. Like we are getting the get capacity and get availability, but actually in fact it's a function, it's a task that is getting done, and after that, after completing both of these tasks, the show status happens. If you come back here, we will explain it in a couple of minutes. If you come back here, after this cryptic checking, we are trying to get the capacity and we are trying to get the available fuel, and this is done through a input function. You can see this input, this is a function. So that's what I was talking about. Getting the capacity and getting the availability is a task, and after we do that, the show status function is getting called. So once the show status function is getting called, the value that we got in container capacity and container availability is sent to this particular function. So whatever value you got here from the user is sent here, and these values, the container capacity becomes the capacity variable here, and the container availability becomes available variable here, and it gets replaced inside the function. That is how the entire code starts working. We can see this in action in a couple of minutes. Let us proceed. After that, the show status activities completes, and then the checking starts whether the container available is less than or equal to container capacity. If that is less than or equal to the container capacity, then we can ask for additional fuel. Again, there is a request for input. This is again a function. After that, the container available, the fuel available is incremented with the fuel that we have filled, and then the check happens. If the container available, that is the fuel available, is more than the container capacity, then what happens is the show status function is called, but this time with the is overflown equal to true value. So when this is overflown equal to true is sent here, this is overflown is changed from false to true. And once the is overflown is changed to from false to true, here it becomes true, and then this particular print statement prints. If the container available is less than the container capacity, then there is nothing wrong. The show status is executed and the status is shown, and finally the expenditure is printed. So we will see the code in action right now. We are going to execute the applying functions program, and you will see that it is asking for the container capacity. I'm going to say 25, and then it is saying how much fuel is available. So it is asking me how much fuel is available. I'm going to say 15 liters of fuel is available, and then it is showing the status to me. So it is saying, okay, there is a 25 liters of capacity and 15 liters of capacity is full. Now it is asking me how many liters you want to fill. So I'm going to say 5 liters. So 25 minus 15, there is 10 liters of available capacity in the tank. I'm only filling 5. And we can see that it has filled the 5 liters. It has increased the available tank fuel, and it has also shown me the expenditure, that is 250 INR. So from this I can sense that per liter costs around 50 INR. Let us do something different this time. So I'm going to say 25, same. I'm going to say available fuel is 15 liters, but instead of filling 5 liters, I'm going to say 15 liters, which is going to overflow. And right now you can see that it is telling that it has overflown. Obviously the fuel is going to be liquid and it is going to overflow out, but graphically here we have shown what has happened. And then the wasted 5 liter of fuel and the total expense is 750 INR. We can right now see that we have written a lot of things with less number of code lines. That is one thing. And another thing that I want you to look is this particular line. Every script has a variable called as double dunder. So this is called as dunder attribute, and because it is having double underscore, this variable name will be printed every time when you are going to execute the script. When you are going to execute the script, this name will be main. So I will show you that right now. So when you are going to execute the script, by default, this main will get printed. Now, I told about reusing the functions. So what if I want someone to reuse this show status and expend? So for that, what we can do is we can use this function as a module and we can import. So for that, we have to start Python ideally. And if I say import applying functions, it will import, and here you will see the applying functions name itself gets printed. So basically what happens is when you import the function, the name of the when you import the module, the name of the module itself is stored inside this name. So when the import happens, the name of the module, the file itself is stored. While you execute a particular file, it is called as main. This is the reason why we use this particular check. In order to know by the Python interpreter that we are executing or whether we are importing, this particular check is being done. If you are going to execute, the name will be main, and then whatever is there inside the main will work. If you are going to import it, then this particular check will fail. So none of these will get executed. None of these will get executed, and these functions that you see here will get imported into the execution environment. If I now say expand, and if I give 6 multiplied by 26, you will see that expand is not defined. Why is this happening? Because we need to mention the module name and the function name. So let me mention the module name and then the function name. So if I say expand like this, then what will happen is it will work. So now you'll see the reply has come. Same way, if you're going to say instead of expand, if I say show status, let us make this 60, and if I execute it, you will see that it is showing the status. Let us go back to the discussion. So in this brief 20 minutes video, we have seen how the function supercharges us to solve the problems, because main thing is it hides the complexity. It helps us to easily test it, and it helps us to put the help in a easier fashion. One thing that I want to reiterate is on the testing. If you look at this particular code, you saw that there is something called as assert. Let us change this value. Instead of 250, let us make this 20, and let us see what happens when we execute the code. I'm going to exit, and I'm going to execute the code right now. You'll see there is an error that arises. So here, this is called as assertion error. Whenever you are writing a function, after you write the function, you can test what is the output that function is going to provide. We are going to multiply two values, and we can actually check whether the multiplication output or the return value of the function is equal to the target. So when you are going to give a two values 50 and 5, the target has to be 250. If it is not, then the code has to raise an error. So that is what the assert keyword does, and that is what also functions helps us to do. By just using the simple assert keyword, we are able to test our function. Whether it is a single line function like how I showed you, or whether it is a 100 or 200 line functions, the same assert function can help you out with this testing. We have seen all these steps and how functions help in this video, and also we saw how the flowchart can make us visualize the flow of the control and the flow of the task, but not the inputs. So most of the time when we look at the flowchart, we think about these are all going to be the input for these tasks, but it's really the flow of the control or flow of the status or the state of a particular task is being modeled. We have after you look at this particular flowchart and this particular function, this particular script, you also understood how easy it is to write a well documented and very understandable series of code, and make life of a coder way more easier. With all these things said, I suggest that you guys actually think about a couple of code that you have already written or executed, and try to write a flowchart like this. That will give you the sense of what is exactly happening in your code. Try to create a flowchart. You already have Draw.io. You can use VS Code extension, or you can download Draw.io application and you can create the flowchart. It's pretty simple. And see whether you are able to create a neat and tidy flowchart. The more easier the flowchart you are able to follow, the better you have written your code and use the function appropriately. So till the next video, where we are going to dive into more interesting data structures and also work with more challenging problems, I suggest 4 things: practice, 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 practice. See you guys. Have a great time.